Hey everyone, this is your Nandini ma'am. Today I'm going to start with the audio chapters of human anatomy, and I'll be taking up volume 1, upper limb and thorax. And of course, we are going to start with chapter 1, introduction. So let's get started. The fore and hind limbs were evolved basically for bearing the weight of the body and for locomotion, as is seen in quadrupeds, for example, cows or dogs. The two pairs of limbs are therefore built on the same basic principle. Each limb is made up of a basal segment or girdle and a free part divided into proximal, middle, and distal segments. The girdle attaches the limb to the axial skeleton. The distal segment carries 5 digits. Table 1.1 shows homologous parts of upper and lower limbs. However, with the evolution of the erect posture in man, the function of weight bearing was taken over by the lower limbs. Thus, the upper limbs, especially the hands, became free and gradually evolved into organs having great manipulative skills. This has become possible because of a wide range of mobility at the shoulder. The whole upper limb works as a jointed lever. The human hand is a grasping tool. It is exotically adaptable to perform various complex functions under the control of a large area of the brain. The unique position of man as a master mechanic of the animal world is because of the skilled movements of his hands. Table 1.1, homologous parts of the limbs: upper limb, lower limb, shoulder girdle, hip girdle, shoulder joint, hip joint, arm with humerus, thigh with femur, elbow joint, knee joint, forearm with radius and ulna, leg with tibia and fibula, wrist joint, ankle joint, hand with carpus, metacarpus, 5 digits, foot with tarsus, metatarsus, and 5 digits. Parts of the upper limb. It has been seen that the upper limb is made up of 4 parts: shoulder region, arm or brachium, forearm or antebrachium, and hand or manus. Further subdivisions of these parts are given in Table 1.2 and Figure 1.1. Table 1.2, Parts of the upper limb. Parts, subdivisions, bones, joints. Shoulder region. Pectoral region on the front of the chest. Axilla or armpit. Scapular region on the back. Bones of the shoulder girdle. Clavicle, scapula. Sternoclavicular joint, acromioclavicular joint. Upper arm, arm or brachium from shoulder to the elbow. Humerus, shoulder joint, scapulohumeral joint. Forearm, antebrachium from elbow to the wrist. Radius, ulna. Elbow joint, radio-ulnar joints. Hand, wrist, hand proper, 5 digits numbered from lateral to medial side. First, thumb or pollex. Second, index or forefinger. Third, middle finger. Fourth, ring finger. Fifth, little finger. Carpus made up of 8 carpal bones. Metacarpus made up of 5 metacarpal bones. 14 phalanges, 2 for the thumb and the 3 for each of the 4 fingers. Wrist joint, radiocarpal joint, intercarpal joints, carpometacarpal joints, intermetacarpal joints, metacarpophalangeal joints, proximal and distal interphalangeal joints. The shoulder region includes the pectoral or breast region on the front of the chest, the axilla or armpit, and the scapular region on the back comprising parts around the scapula. The bones of the shoulder girdle are the clavicle and the scapula. Of these, only the clavicle articulates with the axial skeleton at the sternoclavicular joint. The scapula is mobile and is held in position by muscles. The clavicle and scapula articulate with each other at the acromioclavicular joint. The arm, upper arm or brachium, extends from the shoulder to the elbow, cubitus. The bone of the arm is the humerus. Its upper end meets the scapula and forms the shoulder joint. The shoulder joint permits movements of the arm. The forearm, antebrachium, extends from the elbow to the wrist. The bones of the forearm are the radius and the ulna. At their upper ends, they meet the lower end of the humerus to form the elbow joint. Their lower ends meet the carpal bones to form the wrist joint. The radius and ulna meet each other at the radio-ulnar joints. The elbow joint permits movements of the forearm, namely flexion and extension. The radio-ulnar joints permit rotatory movements of the forearm called pronation and supination. In a mid-flexed elbow, the palm faces upwards in supination and downwards in pronation. During the movement of pronation, the radius rotates around the ulna. See figure 10.23. The hand, manus, includes the wrist or carpus, supported by 8 carpal bones arranged in 2 rows. The hand proper or metacarpus, supported by 5 metacarpal bones, 5 digits, thumb and 4 fingers. Each finger is supported by 3 phalanges, but the thumb has only 2 phalanges, there being 14 phalanges in all. The carpal bones form the wrist joint with the radius, intercarpal joints with one another, and carpo-metacarpal joints with the metacarpals. The phalanges form metacarpophalangeal joints with the metacarpals and interphalangeal joints with one another. Movements of the hand are permitted chiefly at the wrist joint. The thumb moves at the first carpo-metacarpal joint, where an exclusive movement of opposition besides the other usual movements is permitted. Each of the second to fifth digits moves at metacarpophalangeal, proximal and distal interphalangeal joints. Figure 1.2 and flowchart 1.1 show the lines of force transmission. Evolution of upper limbs. The forelimbs have evolved from the pectoral fins of fishes. In tetrapods, all the forelimbs are used for supporting body weight and for locomotion. In arboreal, human ancestors, the forelimbs have been set free from their weight-bearing function. The forelimbs, thus emancipated, acquired a wide range of mobility and were used for prehension or grasping, feeling, picking, holding, sorting, breaking, fighting, etc. These functions became possible only after necessary structural modifications. Appearance of joints permitting rotatory movements of the forearm, described as supination and pronation, as a result of which food could be picked up and taken to the mouth. Addition of the clavicle, which has evolved with the function of prehension. Rotation of the thumb through 90 degrees so that it can be opposed to other digits for grasping. Appropriate changes for free mobility of the fingers and hand. The primitive pentadactyly, limb of amphibians, terminating in 5 digits, has persisted through evolution and is seen in man. In some other species, however, the limbs were altogether lost, as in snakes, while in others, the digits were reduced in number, as in ungulates. The habit of brachiation, that is, suspending the body by the arms, in anthropoid apes resulted in disproportionate lengthening of the forearms and also in elongation of the palm and fingers. Study of anatomy. Before studying the anatomy of any region, it is usual to begin by learning general features of the skin, the superficial fascia and its contents, the deep fascia, the bones, the muscles, joints, blood vessels, and nerves. All these are provided in B.D. Chaurassia's Handbook of General Anatomy, 6th edition. This is followed by the study of the muscles of the region and finally the blood vessels and nerves. These descriptions should be read only after the part has been dissected with the help of the steps of dissection provided in the book. Before undertaking the study of any part of the body, it is essential for the students to acquire some knowledge of the bones of the region. It is for this reason that a chapter on bones, osteology, is given at the beginning of each section. While reading the chapter, the students should palpate the various parts of bones on themselves. The next chapter must be studied with the help of loose human bones. So this was chapter number 1.